So good evening, good evening. So we are training ourselves to, because we know what is ahead of us. We know we are writing supplementary exams. So I might not pronounce the word correctly, but hope you know what it means, sub exams. So sub exams, they are just exams that are given to students who feel their results were maybe were not, fair marked, so they wish to rewrite again. So sub exams doesn't mean that someone is down or someone has a very very low IQ, right? So sub exam is written in order to boost someone's exam, or someone's exams results. So don't feel down, don't feel low, don't feel inferior, all right, to others if you are writing supplementary exams, because these exams are given to students who wish to boost their results and be considered in a career path without carrying any course, right? So in today's discussion, my name is Evaristo, uh, a tutor for Brainfuse Tutorials, Brainfuse team at CBU. Actually, one of the best tutorials in school. So today's discussion, as requested by one of our members, said we need to start from at least units and measurements. So I believe we are going to touch, something. We are going to see something about units and measurements. And I hope you can see what is on my screen. This is from units and measurements, PH 110. All right, so these are sessional papers, PH 110, Physics 110. Some say Phi 110. So question D is saying the speed V of an object is given by the equation, right? Where T refers to what? Time. What are the dimensions of A and B? What are the dimensions of A and B? So now, you need to understand dimensions, all right? The first introduction, you looked at, when you just came to CBU, you looked at dimensional analysis, right? When you just first came to CBU, you looked at dimensional analysis, right? So what is dimensional analysis? Dimensional analysis is just a process or procedures that are carried out in order to verify or to derive an expression or equations. So that's why now, number one, we have uses of dimension analysis. Number two, we have limitations of dimension analysis. So as a student, you need to know the uses of dimension analysis and the limitations of dimension analysis. It is from these two where all questions are asked, all right? Now, the most two important uses of dimension analysis that I love to talk about, to tell every student, right? If you look at the uses now, of dimension analysis, I love to talk about number one, they are used to derive equations, right? Number two, dimensional analysis is used to show homogeneity, or consistent of equations, right? So these are the two most important uses of dimensional analysis. Number one, they are used to derive equations. Number two, they are used to show homogeneity or consistent of an equation. So what do I mean by homogeneity? I mean, for example, let's have this equation, force equals to mass times acceleration. Now the question can be, is this equation homogeneous or is this equation consistent? That's how the question is going to be phrased. So now, how do you prove that this equation is homogeneous or consistent? So what you do is, consistent or homogeneous equation, it means what is the units on the left-hand side must be equal to the unit C on the right-hand side, all right? So your job is to know the basic units of force and the basic unit of mass times acceleration. Now, if you find that the basic units of force is equal to the basic unit of mass times acceleration, then you conclude to say this equation is homogeneous or consistent or correct, all right? Now, apart from the uses of dimension analysis, there are also what we call limitations, right? There are also what we call limitations. So limitations of dimension analysis, number one, these dimensions are only applicable to mass, dimension of mass, dimension of time, and dimension of what? Length. This is a limitation, all right? Now, the second limitation is dimensional analysis can only derive one part of an equation, all right? Of an equation. One part of an equation. Dimensional analysis can only derive one part of an equation. This is the limitation. Why can't it derive all the parts of an equation? All right? So the limitation is it can only derive one part of an equation. And this is the limitation. The other one is dimensional analysis is only applicable to mass, dimension of time, and dimension of length. All right? Now, the third limitation is dimensional analysis does not give the actual value of the constant k. The constant value can only be found by performing an experiment, right? The fourth limitation is dimensional analysis cannot simplify expressions or equations consisting of trigonometry functions, exponential functions, and logarithmic functions. These are the limitations of dimensional analysis. Now, among these limitations, they got one question from here, one part of an equation. Dimensional analysis does not derive more than one part of an equation. And this is how we are going to apply this limitation here. And this is the question that is here. This is the question that you are seeing here. This question is a limitation, all right? This question came from the limitations. So you just need to master all the limitations and know how they ask questions on each limitation. So it's important to know the uses and the limitations of dimensional analysis because all questions come from the uses and the limitations. All these questions come from, so this question comes from the limitation, right? This question comes from the uses, and this question comes from the uses. This is deriving of an equation. So now let's apply that limitation only derives one part of an equation to answering this question now. So the equation is the speed v of an object is given by the equation v. So dimensional analysis, I forgot to mention that dimensional analysis, we talk about units. This is what you should know. Dimensional analysis, we talk about what? Units. So meaning each quantity, every quantity they talk about, you need to know the units of that quantity. And not just like any other units, like derived units. I'm talking about basic units. You know basic units? Basic units are independent. You cannot derive basic units. For examples of basic units, kg, for mass, because mass is a physical quantity. We have, basic units like, time, basic units like length. And these three are applicable to what? Only applicable to dimensional analysis, right? So V equals to what? AT cubed minus BT, where T equals to what? Time. Find the dimension of A and B. So let's try that. Let's try to find, so the equation was V equals to AT cubed minus BT. And then they are saying find the dimension of A and the dimension of B. You know that there are only 3 dimensions. Dimension is denoted using 2 square brackets, all right? And inside you put any letter of your choice. So we have 3 dimensions, dimension of length and dimension of what? Mass and dimension of what? Time. These square brackets we are seeing here, they mean dimension I. These square brackets we are seeing here, they mean what? Dimension. So if you are writing a dimension, you need to put the square brackets. And these are the only dimensions that we have. Length, mass, and time. All right? Meaning, in all the units that you have, these 3 should appear. The mass, length, and time. Length, mass, and time. So now, they said the speed V. So V is speed. You need to ask yourself. Remember, dimensional analysis, we talk about units. So you need to ask yourself, what is the unit of V, speed? Units of velocity is what? Units of velocity is what? Meters what? Meters per second. Dimensional analysis, see, you need to know the units, please. Know the units. There is another thing that they defined here. They defined T. What did they say T is? T is what? Time. So what is the dimension of time? What is the dimension of time? Or the units of time? Second. Yeah, so the units of time is what? Second. Now, remember, this is meters per second. So what is the dimension of meter? Length. Meter is length. What is the dimension of second? Time. Have you seen? Simple. If I had kg, I would have put the dimension of kg is what? Mass. Simple. So now, how do you find the dimension of A and B in this scenario? Remember one dimension. It said dimensional analysis can only derive one part of what? An equation. So it means this V equals to that, and this V equals to that. Forget about the negative, all right? It means we can only derive the relationship between V and AT cubed. And again, separately, we can derive the equation between V and BT. That is the meaning of it can only derive one part of an equation. Meaning, this V can be related to AT cubed. Again, this V can be related to BT. Hope you understand what I mean, Yeah, I hope you understand. So whenever you see something like this, just know that this one equals to that and this one equals to that. And then make A subject to a formula, solve. Make B subject to a formula, solve. In terms of units, all right? And since you know the units, it means you know the dimensions, right? Yeah. So let's move on. So we know the dimension of V is what? Meters per second. But in terms of dimension, we are going to say meters, which is dimension of L, per what? Per second, which is what? Dimension of time. So L per T. So we're going to say V equals to A T cubed. The other one is going to be what? V equals to what? BT. This is what I meant when I said it can only derive one part of an equation. All right, I've just equated V equals to that, V equals to that. So forget about the negative that was there. I know there was a negative here. All right, forget about this negative. It has no use, Yeah. So now, from here, we are going to write the dimension of V, velocity, and the dimension of time. Then we make A subject formula. Again, here we are going to write the dimension of T and make B, and the dimension of V, and make B subject formula. So from here, let's first move on. So let's start with this one. We are going to make A subject formula from here. Let's make a subject formula. So we are going to divide by t cubed, also here by what? T cubed, all right? Then we say A equals to V over T cubed. Now, in terms of dimension, what is the dimension of V? Meters per second. So we're going to say dimension of L over dimension of what? Time. Divide by what? Divide by dimension of T is what? What is the dimension of T? Capital letter T times Z, or divide by time. Now this time what? Cubed. Because it is cubed here. As you can see, it is cubed. Yeah. So now we can now you know that whenever you have a division here, you can just rearrange L over T times what? Remember here there is 1 times, so 1 will be on top, this one is going to be on top, and this T is going to be down, T cubed. So I'm going to have 1 over T cubed, right? That's what we're going to have. Then this equals to L per T to power 4. So this is the answer, right? So that is the dimension of A. L per T 4, right? So now we can just now write to say dimension of A, we do this, equals to L per T 4. That's all. If you want, you can just bring this denominator, it will go up here, and the sign of the power is going to change. So it's going to be, or dimension of A equals to L T to power negative 4, right? So that's the answer. So it's just a matter of equating this quantity equals to that, this quantity equals to that, and make the letter subject of formula, and then simplify. After you simplify, you can take the denominator, be the numerator, and change the sign of the power. So today you're just going to forgive me. I'm just going to do this question here. I'm just going to do this question. Then tomorrow morning, I'll send more videos before we start the live lesson around 21 hours. I think by that time the network is okay. So now let's now find the dimension of B. So we're going to equate this one equals to that one, like we said. It derives one part of an equation. So this is the part we're talking about. V equals to BT. So we have V equals to BT. So to find B, we are going to divide by what? T. Make B subject formula. So we have B equals to velocity over what? Time. Speed over time. So now we ask ourselves, what are the units of V, meters per second, and the units of time, seconds? Now what are the dimensions? L per what? T. Also this one, T. So we are going to say L over T divide by what? Divide by T. So now dimension we should be put. If you are not putting if so, that already code so it's better you put them here. Once you put them at the start, it means you have defined whatever you'll be doing here. But if you don't put these to my square brackets and then you are just leaving it like that, you are not putting to my square brackets, they will mark you wrong. So as you can see, I'm putting first of all Utuma square brackets, then I write them without Utuma square brackets. If you want, don't put the square brackets here and put them in there as you are working out things. So equals to what? L over T times, I'm going to change here, division changes to multiplication, and then the denominator is 1, it's going to be the numerator, and this one is going to be the denominator. So L times 1 is going to be L over T times T. T is going to be T square. All right, so this is the dimension. So it just concludes to say, therefore, the dimension, you put a square bracket, dimension of B equals to whatever is the denominator, make it the numerator, LT, and once you change, as you can see here, T squared is the denominator, it will be the numerator, and the power, what is the power? Positive 2, T to power positive 2. So the sign of the power is going to change to T to power negative 2. So I'm going to put a negative 2 there. Then this is the dimension. If you don't want to put my square brackets per first, what you can do is, this is the other way. You can just say, oh, B equals to what? L. Have you seen what I've done? Then T to power what? Negative 2. If you want, you can write it like that. There is no problem. But if you don't want to save time and you don't want to put the things like that, you can just put them here, then you write them like that. So thank you so much for staying up to this far. Today I was just so confused. We'll do more tomorrow morning. I'll try by all means to finish some questions here, and then in the evening. But you are free to ask me questions. Please make sure that you ask me questions. All right. And mostly remind me when you're supposed to meet. When I say time we are going to meet, before 30 minutes, please remind me. Sometimes I sleep a lot. So just remind me. And then don't keep the quiet, don't let the group be quiet. Please ask me questions, right? Whatever you are studying in physics, you are just remaining with 1 month. You are the one who's going to be writing the exams. Please make sure that you ask me questions. Whatever you are studying, just post in the group. Evaristo, help me. Evaristo, help me. I'm solving this. Is this correct? This is how we will learn, because we have 1 month remaining. Don't wait for me. Please do practice and ask me questions in the inbox. If you want, send in the group. I'll be able to assist. Have a good night.